Alright, in this lesson we're going to move from talking about polar and nonpolar bonds to talking about polar and nonpolar molecules. So when we talked about bond polarity, we were only talking about the bond polarity between two nonmetal atoms within a molecule, and so we only dealt with the electronegativity difference. When we talk about molecular polarity, we were talking about the entire molecule encompassing all the covalent bonds within it. So this depends on both electronegativity difference and shape. So in order to be a polar molecule, there's two things that have to happen. One, there has to be at least one bond that is polar, which means it has an electronegativity difference greater than 0.4, and the shape cannot cancel out, which means that it's an asymmetrical shape, and we'll talk about how to determine that. We also say that a polar molecule has an uneven charge distribution. So a couple little tips. We're going to see that polar molecules do not pass the mirror test. And while it may have one line of symmetry, it can't have more than one. If there are two atoms, they have to be different elements or electronegativities. If there are more than two atoms, look for lone pairs around the central atoms. So the first thing we want to look at with a molecule is look at the bond polarities. So I'm calculating both the CH bond and the CCl bond. And I can see that with the CCl bond, I do have at least one polar bond. When I check the symmetry of the Lewis-S structure, I only have one line. So the thing with the mirror test is that you have to have at least two or more lines in order to pass the symmetry test. If I only have one, we're going to say that it does not pass and thus is asymmetrical. So if we have at least one polar bond, and the shape is asymmetrical, then we have an uneven charge distribution, which results in a polar molecule. When we check HCl, we have a difference of 1.0. I can only have one line of symmetry, so we have both a polar molecule and an asymmetric shape, which means we have an uneven charge distribution and another polar molecule. When I complete NH3, I get a 0.8 electronegativity difference. In my structure, I can only draw one line of symmetry, which means it does not pass the mirror test, because again, we need at least two. So again, we have another case where we have both a polar molecule and an asymmetrical shape, which means we have an uneven charge distribution and a polar molecule. One thing I want to note that will tie into when we talk about intermolecular forces is that because we have this uneven charge distribution, we get slightly charged regions within the molecule. So, such as with oxygen and two hydrogens in water, oxygen, which is the more electronegative atom, pulls the electrons shared towards it, unlike the hydrogens where the electrons are spending less time around. And when that happens, we will discover that oxygen has a slightly negative charge, and the hydrogens develop a slightly positive charge. And we'll talk more about that in class. Now, to determine a nonpolar molecule, one of the following two has to occur, but not both. All the bonds have to be nonpolar, which means they have an electronegativity difference between 0 and 0.4, or we could see that we have a shape that does cancel out, meaning that we have a symmetrical shape. Nonpolar molecules will always have an even charge distribution. So a couple of things for identifying a nonpolar molecule: it should pass the mirror test, which means we can draw at least two lines of symmetry. If there are two atoms, they're going to be the same element or the same electronegativities. And if we do have more than two atoms, we're not going to find any lone pairs around the central atoms. So with CH4, I have a 0.4 bond, and we can see the structure here, which does have multiple lines of symmetry. So since we have a nonpolar bond and it's symmetrical, we have even charge distribution, which means we have a nonpolar molecule. If I look at CO2, I have for each CO bond a 0.8, and in this case we have multiple lines of symmetry. So even though we have a polar bond, because we have a symmetrical shape, we have even charge distribution and a nonpolar molecule. And then finally for CCl4, we have both a 0.6 bond, so we have a polar bond, and we have multiple lines of symmetry, which means we have again a polar bond that is with an asymmetrical molecular shape, which means we have an even distribution of charge and thus a nonpolar molecule. Alright, we're going to go into this much more tomorrow, but hopefully this gives you a little bit of a background on what a nonpolar and polar molecule are.